Here's another thinking question on equivalent algebraic expressions from the test paper. So let us explore this rational expression and sketch its graph. Question is, given the rational expression f of x equals to 2x squared minus 7x plus 3 divided by x minus 3, you need to simplify this expression, state restrictions, and sketch the graph showing any asymptotes, holes, or x or y intercepts. You can pause the video, answer the question, and then look into my suggestions. Now let us first simplify this rational expression. Numerator is 2x squared minus 3x, 7x plus 3 divided by x minus 3. We should be in a position to factor this. We are looking for two numbers whose product is plus 6 and difference is minus 7. So the two numbers which we could do is minus 6 and minus 1. So we will write this as 2x squared minus 6x minus x plus 3 divided by x minus 3, right? So let's continue. So I'm doing it in steps so that you understand how we get the answer, right? So in the first two terms you can take 2x common. You're left with x minus 3, and we have x minus 3 when you take minus 1 common from the last two terms also. Now we can take x minus 3, and you're left with 2x minus 1 divided by x minus 3. Well, it's a good time to write restrictions before you cancel these factors. So the restriction is we cannot have denominator equals to 0, and we say x is not equal to 3. That is the restriction. Now the other part is, in a rational function we have a common factor in numerator and denominator. It can be cancelled. But whenever you cancel, you have to write here that x is not equal to 3. Only then this expression is equal to what is left, right? So we'll simplify and write this expression as equal to 2x minus 1, where x is not equal to 3, correct? So that is the answer for the first one. Simplified expression is that f of x is equals to 2x minus 1, where x is not equal to 3. Well, part B is state restrictions, which is clearly x is not equal to 3. Now 2x minus 1 is a straight line. Part C is sketch the graph showing asymptotes, holes, x or y intercepts. Now let us try to sketch the function. Now this rational function will not have any asymptotes, right, since it is not approaching a value, but it will have a hole. The hole will be at x is equals to 3, because we had a common factor x minus 3, and the common factor in numerator and denominator leads to a hole, correct? Now let's sketch the line 2x minus 1, where x is not equal to 3, which represents the function f of x. Is that okay? Y-intercept is minus 1, so that is 1 point, y-intercept. Slope is 2, that means rise of 2, run of 1. We get another point, and likewise we get more points. We can connect them, right? So that is kind of a neat sketch for us. But the only thing which you have to remember is that at 3 the value will be 6 minus 1, 5. So this is 1, this is 2, and then at 3 we'll have a value here which is 5, where you have to make a hole, correct? So make a hole at that place and then draw the rational function. So your rational function actually is like this. Do you see that? So it is kind of important to show the hole very clearly. So that is the hole, and the location of the hole is at x equals to 3, and f of x will be at this point 5, right? 5. So we can say hole is at 3, 5, correct? So you have to clearly show that hole, right? So you have an x and y intercepts. Y-intercept is minus 1. So we are trying to sketch the function f of x, which is equals to 2x minus 1, where x is not equal to 3. So this is the point where it has a hole. Y-intercept is minus 1, right? So If I put x equals to 0, you get minus 1. What is the x-intercept? If I have x 0, then we get half. So this point is half for us. So let me write half as 1 over 2 right there. So that is the x-intercept. And a whole is at 3, 5, right? So we have x-intercept at half 0, y-intercept at 0 minus 1, and we have a whole at 3, 5, correct? And it looks like a straight line with a whole at x equals to 3. So that is how you have to sketch and describe your rational expression. I hope that's absolutely clear. Thank you and all the best.